Hello, thanks for being here. And today I'll be talking about building strongly typed API thanks to Kotlin Ktor. So, it will be everything about Kotlin and see how we can use it to build like strongly typed APIs. As an introduction, my name is Julien Salvi. I'm the lead Android engineer at Aircall. I do mainly Android, but I love doing some backend stuff. So here we are, and I love using Kotlin. So you'll see it's a great language to build also on the backend side. And by the way, I'm an Android GDE, and you can find all the things I share about tech stuff on Twitter. So I mainly cover what is Ktor, so I'll be doing a bit of overview, what is this framework, and how we can use it for building API stuff. And then we're going to see all the main plugin of Ktor and how we can use it to build strongly typed APIs and see how we can interact with the Swagger file to have a single source of truth and a great documentation and like all the things that Swagger allow us to play with. So let's first have a little introduction about Ktor. So Ktor is developed and maintained by JetBrains. It was released, the stable release in 2018. And the latest one is the 2.1 and has great capabilities. So it's an asynchronous framework written fully in Kotlin. And it allows us to build web services, web app, web clients, and much more. So Ktor is a very lightweight framework. You can use a lot of plugins, and it's an easy configuration, very extensible. Also, the main advantage is Ktor is multi-platform, so you can use it for your mobile apps, your backend application, or your web apps. And also, Kotlin is asynchronous. So thanks to Kotlin coroutines, we can build high scalable microservices. Okay, so let's see how we can build our strongly typed API thanks to Ktor. So we're gonna set up our default route, see the main Ktor plugins like status pages, resources, content negotiation, and how we can deal with our Postgre database thanks to the expose library, and see how we can validate our data thanks to Validator. And in the end, we'll take a look at our Swagger integration. So let's go. Let's build our type API. So classic REST API, and so it's like a cooking recipes. So classic. So you can get recipes, create new one, get ingredients, add new step to recipes and so on. But what is very interesting for us is here on the server side, let's say, how we can make this API strongly typed. So from our mobile app or web app, we're going to send a request. Like, for example, I want to post a new step in my recipe. So it will be /recipes/ the UID of the recipe /steps. So we're going to see how we can validate the typing of the route, the payload validation, and all the constraints associated to the payload. So we're gonna then deal with our database, so insert the data and then send the response back. And we're gonna validate this response to be sent to our mobile app or web application. So we're gonna build this strongly typed API thanks to all of this. So the main plugins of Ktor, like resources, content negotiation, status pages, and few other third-party library, Validator, Coin, Expose, and so on. So these are all the tools I used to build this type API. So let's see first how we can type safe our route. So thanks to the resources plugin, which relies on Kotlin serialization, so like to define and use all the basic types of Kotlin, like integers, strings, boolean. Everything is in this by default. So we can get, we can create our route, like the default one, get, post, patch, delete, and so on, all the things associated to REST. So we can create our object, so define our route layer by layer. So let's say we create a class annotated by /resources/recipes, And then we're gonna define the route for like targeting one specific recipes. So here we're gonna create another nested class, and we're gonna pass the parameter we want. So the parent, and for example here to fetch or post a new recipes, fetch a new one actually. We gonna validate that our route is using a UID and not like not an int or not a string, but a UID. And UID is not like clearly supported by default by resources, so we're gonna have to implement a serializer to manage this UID. Another way to define our route is to use a single class. So for example, like here to get an ingredient from a recipe, we're gonna define like the data class for this specific route and define all the parameter we want to pass in this pass. So I was talking about like implementing a custom serializer because UID is not supported by default, and it's pretty straightforward if you want to implement your custom one, like the UID here. So you're gonna decode and so deserialize and deserialize your UID. And in your main module application module, so I'm gonna install the resources and use and define our routing lambda, and then here in my routing lambda, I'm gonna define all the route I want, like the get, post, patch, delete, and so on. And everything will be typed. So if you pass, for example, an integer instead of a UID, you'll get an exception and you'll get an error. So it's pretty straightforward to implement the get request. You can get parameters and then respond depending of the work you want to do and want to achieve on your backend side. Same for post request. You can get the body, and it works pretty straightforward also for uploading files, for example, with the multi-part data. So now we've validated the route, and now we want like to build our request and body. So we want to make them like strongly typed, and we're gonna use Moshi to define all these objects. So Moshi is a JSON library made by Square, so it allows us to like to deserialize and serialize data. It's very lightweight, no HTML escaping, custom adapter. So it's very commonly used on the Android side, but you can also use it on the backend side. And it has a very nice interoperability with Swagger, and I'll come back later on that. So we're gonna define all our responses and payload we are going to deal with. Like for example, here the post of a new ingredient, the get response for an ingredient. So I'm gonna define my field and the object that gonna be included in that response or in that payload. Okay, so we have our object, but now we want to make sure and validate that all our objects that are coming and requests that are coming from our mobile app are good for our use. So we're gonna use here a third-party library called Validator. So it will allow us to validate the data that is received by our backend. It's a type-safe DSL, so to validate this object, and it supports also suspending function, so you can do stuff on in the asynchronous way with coroutines. And it has multiple extensions with Spring, Joda, and so on. So let's say, for example, we receive a post request to add a new step to our recipe. So I have a position, a description, and a preparation time. So our position is a long, we have a description as a string, and a preparation time as a long. So thanks to Validator, we can validate all these fields. Like, okay, I want my position to be non-null, and greater or equal to 0. I want my description to be not null and not blank, and so on and so on. So all my fields will be validated. And if there is something wrong, we're gonna throw a constraint violation exception. So like this, we won't have any surprise on the client side and on the backend side. So you have to follow all the rules to like make things work. And so in your implementation of your route, so when you post your new recipe, we're gonna get the payload. So here the post recipe request, and we're gonna call on it .validate the extension function we just created before. So if there's something wrong, there is an exception. And we want to deal with this exception. So we're gonna use here status page in order to handle properly this error and exception that might be in your backend. So 3 configurations possible. You can catch exceptions, status code, or status file. And it's very simple configuration. So we're gonna install the Ktor plugin. So I'm gonna handle, install status page and create an extension function called exception to handle multiple exceptions in my backend service. So in this extension function, I'm gonna define, okay, so every time there is a constraint violation exception, I'm gonna catch it and like send a proper response with a status code like unprocessable entity, with some details about what went wrong with this exception. Or you can like do a wider thing and catch all the throwable in your application and respond that, okay, there is an internal server and something went wrong, but like no particular reason. Okay, so now we've validated all like the front side of the API. Now we want to deal with our database. So thanks to the Expose library, we can manage that. And so Expose is an ORM framework developed by JetBrains, again, fully in Kotlin. And it supports multiple databases like Postgre, MySQL, H2, MariaDB, and so on. And to make the connection between that, we're going to use JDBC and EKRecipe. So to query our database, we will be able like to use a DAO API or DSL, and it supports like all the basic CRUD operation or advanced one. Okay, so defining all the library we want in our dependencies, so in our Gradle dependencies. And then we're gonna create our table. So like for example, here I'm gonna create my recipe table with the like title, description, cooking time, and so on. So all the columns that are belonging to the table. And then we're gonna have a recipe class in order like to make the operation on the table, like to add something, query an entity, and update like all the CRUD operation. So we're talking about CRUD operation. So thanks to my recipe class, I can create a new entry in my database thanks to the .new function, or fetch a recipe thanks to its ID, update a recipe, like I want to update the title, so I'm fetching the recipe and fetching also the title to update it. And very easy also to delete an entry with the function delete. And to like handle all these transactions, so we have few things here. So we can like do a basic transaction, like to like query, update an entity in our table, or we can use and take advantage of the coroutine to make things a bit asynchronous and use like suspending transaction and suspended transaction async. So depending on the dispatcher you want, here, for example, if you want to make things a bit asynchronous and work in parallel, so we can use the dispatcher IO and make our operation fully asynchronous. So it also like enable us like to have some referencing. So easy implementation of the many-to-one relation. So for example, here, a step table, in my step table, I have a reference to like some recipe and videos, because a step is potentially associated to to a video and have for sure a recipe. And thanks to the keyword reference on and optional reference on, we can like define this relation. So optional or strong one. And it also supports the many-to-many relation. So here we're gonna create like a join table recipe and ingredient to allow us to query ingredients from the recipe or query recipes from the ingredient object. And that's pretty much it. Like, thanks to all the Kotlin languages and the tooling that is around Kotlin Ktor, we have now our strongly type API. And now let's see a bit about like Swagger to have a very strong contract with your clients and have only source of truth for your API. So here, for this sample, I used the Swagger Gradle codegen in order like to build my models for like my remote models for my Android app, for example, and the entity that will be sent and validate from my API. So this plugin is developed and maintained by Nicolas Corti, and it relies on the OpenAPI format. So great for RESTful web service, support YAMLs, JSON, and so on. So nothing new about Swagger here. The nice thing is, thanks to this plugin, we can generate retrofit interface for our Android app and our models for our Android app and our backend service. Okay, so we have our module, and let's take a deeper look at what we have when we launch the script. So here we have not API client YAML, which is our Swagger file, and it's gonna build all the APIs and all the models we want to use. So in my Gradle build, so I'm gonna define the generate Swagger function. So I'm gonna use the Kotlin coroutine as a platform. Want to target this package name, for example, and say, okay, I want my build to be in this directory. So I'm gonna define in my Swagger, so all my routes, all my parameter, all my object, and it will be strongly typed. So the int will be a string, a UID, and so on. So no surprise. And then it's gonna generate our retrofit interface for our Android app and our model that we will use on the Android side and also on the backend side. So it's gonna allow us to build our front model for our backend and remote model for our Android app. No more surprise in the types, so strongly type on both sides. And like this, thanks to Swagger, we will have a strong contract between our clients and API. And the release, like with the latest version, Swagger integration. So there is a new plugin in the Ktor framework. So it's called Swagger UI. And like this, in your dev environment, you will be able like to have a Swagger view and interact with your web service thanks to a Swagger page. So part of the Ktor plugins, and you can use also the OpenAPI plugins if you are using OpenAPI for sure. So in your application module, you define in your routing the Swagger UI with your path and the Swagger file you want to display. And I'm gonna give you a little demo of that. So here my application is running. I can target my recipes, and if I want to like to display my Swagger file, up. You will have like the Swagger UI to interact with your API. Very straightforward, fast integration, and like this you can expose the documentation to your developer, and they're gonna have the opportunity to play with the API. can find all the samples and the code of the API built with Ktor on my GitHub. So here is the link if you want to have a look. And if you have any question, I'll be very happy to answer here or later about Kotlin, Ktor, and other stuff. Thank you.